So students, let's start activity 1.2 Venn diagrams. So our objective for the given activity is to represent set theoretic operations using Venn diagrams. So students, now let's start method of construction for the given activity. So our first step, draw 20 rectangles on a white chart paper. And draw the symbol U and draw the symbol U on the top left or right corner of rectangle. Suppose this is our rectangle, so we can mark U on the top, right or left corner. So this U represents universal set. Step 2. Draw two circles A and B inside the rectangle. And shade their different portions. Now follow this step in all the 20 rectangles. Now step 3. U denotes universal set. Now this U in the rectangle represents universal set. Step 4. Circles A and B represents the subset of universal set U. So here A and B are the subsets of this universal set U. So students, now let's see the demonstration for this activity. First, representation of universal set in Venn diagram universal set U is represented by a rectangle. So this rectangle represents universal set U. Second, representation of set. We represent each set by a circle in universal set U. This is the universal set. So this rectangle represents the universal set, and the two circles are the set A and set B. That is, A and B, the two circles, represents the two sets inside the universal set U. Activity 1.2. So now, third, representation of subsets. A set A is said to be Point 3. Representation of subsets. A set A is said to be the subset of set B if all the elements of set A is also the element of set B. That is, each element of set A should be the element of set B. Then we can say set A is the subset of set B. If all elements or each element of set A is also the element of set B, then we can say set A is the subset of set B. Let's show it using a Venn diagram. So this is a universal set, and let's draw a circle that represents set B, set A and set B. So now we can clearly see that set A is the subset of set B. Similarly, every set defined inside the rectangle, that is the universal set, is the subset of universal set. Suppose this is set A, set B, set C. So we can say set A, set B and set C are the subsets of universal set U. Since A is the subset of B, so it is represented by symbol and here A is the subset of B, so this represents A is the subset of B. So in this way we can represent A as the subset of B. So symbol. So students, now part 4. So students, now fourth point, representation of union of two sets. So a set is said to be the union of two sets A and B. Suppose there are two sets A and B. So a set is said to be the union of two sets A and B if the elements, if its elements either belong to set A or set B or both set A and B. It is denoted by symbol so the union of two sets A and B is represented as A union B. So this is how we represent the union of two sets, set A and set B, and this is A union B. So in a Venn diagram we represent A union B. This is our universal set. This is set A and this is set B. Then A union B is all the elements, that is, it can be either elements of A or the elements of B or the elements of both A and B. So this represents Venn diagram for A union B, that is the shaded part. So A union B is composed of all the elements of set A and set B. So students, now point 5 is representation of intersection of two sets. So intersection of two sets A and B is the set that has the common elements between A and B. It means a set that has the common elements of A and B, that set is said to be the intersection of A and B. It is represented as A intersection B. Now let's represent it on a Venn diagram. This is the universal set. This is set A and this is set B. Now to represent A intersection B, we shade the common elements between A and B. So the shaded region represents A intersection B. Now in 6th point we will see representation of disjoint set. If there is no common element between two sets, then that set is called a disjoint set. That is where A intersection B is equal to 5. So the two sets are said to be disjoint set when they have no elements common between them. Suppose this is a universal set. To represent a disjoint set, so this represents a disjoint set, that is A intersection B equals to 5, since they have no common elements. The elements of A are completely different from the set of set B. The elements of set A are completely different from the elements of set B. So this set is known as disjoint set. Now our seventh point is representation of complement of a set. Suppose we have a set A that is defined under universal set U, then the complement of set A is the set of all the elements of universal set U except the elements of set A. Complement of set A is denoted by A dash. So, if we represent it in a Venn diagram, so this is the universal set and this is the set A, then complement of set A is all the elements except set A, that is this shaded region represents A complement, that is it contains all the elements of the universal set except set A elements. Now our eighth point is representation of A complement when A and B are disjoint sets. Now we are familiar with what is complement of a set and what are disjoint sets. So let's represent this using a Venn diagram. Suppose this is a universal set, and in universal set we have two disjoint sets, that is A and B. So disjoint sets that does not have any element common between them are disjoint sets, that is set A and set B. And now complement of A is the elements of all the complement of A is the elements of universal set except the elements of set A. So except the elements of set A, we include all the elements that is set B as well. So this shaded region represents complement of set A when A and B are disjoint sets. A complement, elements of or all elements of the universal set U including B except the elements set A. So except A, all the elements in the universal set is A complement. Now, in our ninth point, we'll represent B complement when A and B are disjoint sets. So now, we know how to represent disjoint sets and complement of a set. Then we have a universal set and two disjoint sets A and B, and we have to find B complement. Then except B, all the elements of the universal set is called B complement. So shaded part represents B complement. So now our 10th point is representation of A union B when A and B are disjoint sets. So now let's represent it using a Venn diagram. So this is a universal set and two disjoint sets A and B. So A union B when A and B are disjoint sets. So A union B means all the elements of set A and set B. Since the two are disjoint sets, so A union B will be all the elements of set A and set B. So this is A union B, where A intersection B is equal to 5. That is, it represents that A and B are disjoint sets. All the elements of A and B constitute to form union of A and B. So students, now our 11th point is representation of A union B when A is the subset of B. So this is a universal set and A is the subset of B. It is represented as two concentric circles, where bigger circle represents set B and smaller circle or the inner circle represents set A. So we can say set A is the subset of set B, as set B contains all the elements of set A. Then we have to represent A union B. So to represent A union B, that composition of elements that contains both the elements of sets A and set B. So some distinct elements of set A and set B represents A union B. So the shaded region represents A union B. That is, all the elements of set A and set B. We can say all the distinct elements of set A and set B represents A union B. So this is A union B. Or we can say set B. As set A is included in set B, so set B is the union So set B is the union of A and B, as A is included in set B. So students, now in point 12, representation of A intersection B when A and B are disjoint sets. So let's represent it using a Venn diagram. First we will represent two disjoint sets A and B. This is set A and this is set B. So disjoint sets are sets that does not have anything common between them. So A intersection B of these sets is equal to 5, as disjoint sets does not have anything common between them, and intersection means the common elements between the two sets. So there are no common elements between set A and set B, so it is a null or 5 empty set. So intersection B is an empty set. So students, now point 13, representation of A intersection B when A is the subset of B. So first, let's draw a rectangle representing a universal set. Now, A is the subset of B, so let's draw two concentric circles. Set B and A is the subset, that is, A is contained in B. Since A is the subset of B, so A intersection B corresponds to set A. That is, all the elements of set A is equal to A intersection B. Here, the shaded region represents A intersection B when A is the subset of B. Now, point 15, representation of B complement when A and B are two intersecting sets. So now, let's represent it using Venn diagram. So this rectangle represents universal set, and in this universal set we have set A and B that are intersecting sets. So this is set A and this is set B. So they are intersecting sets. Now the complement of B complement is all the elements of universal set except the elements of set B, that is, all the elements including So the shaded region represents A complement when A and B are intersecting sets. All the elements of B and all the elements that are common between A and B, all the elements of universal set denote B complement. The shaded region denotes B complement where A and B are intersecting sets. That is, A intersection B is not an empty set. Then the shaded region here represents B complement. Now in 16th point we will represent A intersection B complement. So first, in the Venn diagram, we will represent this is universal set A intersection B. This is set A and this is set B. And the region between them is A intersection B. Now this is A intersection B. A intersection B, that is the common between the two sets A and B. And now we draw the Venn diagram. Now we will draw A intersection B complement. So complement means all the elements except that set. So A intersection B is this set, so A intersection B complement will be all the elements except the common element between the two sets. That is all the elements of universal set except the common elements between So this unshaded part represents all the shaded part. So the shaded part represents A intersection B complement. Now point 18, representation of difference of two sets A and B. This is a universal set and two sets A and B, that is two intersecting sets A and B. The difference of two sets A minus B is the set of elements of set A that are not in set B. Or you can say the elements that are not common to the elements of set B in set A is termed as the difference of two sets A minus B. So here in Venn diagram we will represent difference of two sets A minus B, then all the elements that are not in set B, that is all the elements of A different from set B or not common to set B. So the shaded region represents A minus B, or the difference of A and B. So students, now in point 19, representation of A complement intersection B. So let's draw the Venn diagram. This is the universal set, this is set A, this is set B, and A complement is all the elements of universal set except the elements of set A. And now A complement intersection set B will be set A, set B, This is the universal set, set A, set B, and now the intersection of A complement and set B is this shaded region. As you can see, the common between the complete A complement and B is represents A complement intersection B. So the shaded part represents A complement intersection B. So now point 20 is representation of A complement union B. This is universal set. This is set A. This is set B. Now complement of set A is all the elements of the universal set except the elements of set A. So this is A complement, and as you can see, so A complement includes the elements of set B also. So we can say A complement is equal to A complement union B. So the shaded region represents A complement union B. So students, from this activity we conclude that any set theoretic operations can be represented by using Venn diagram.